Hello.
Hello, sir.
Hi, how are you? Yeah, good. All right, so welcome. So it's like Kavya's here and Ashu and Barshan. Um, Jesse, I think, will be here momentarily, and maybe Morgan. So I don't know if anyone wanted to present anything or update us on anything that they've done over the last week. I know Barshan, of course, has been working hard.
Yeah, so I had an update.
Okay.
All right, so I made a presentation.
All right. Go ahead and
I'll
share
also
your
prepare a
screen.
blog, but it's not deployed yet, so I can't
Oh, that's fine.
show that. Okay. So this week, my plan was, according to my proposal, was pre-process the data and extract and make it ready for basically the model which I'm going to make. And so basically, what I made was a data loader or a dataset loader. And what I thought was that what if I extend this into working on different, like a lot of embryos together, or working on a single embryo as a singular and analyze on it. So the dataset loader I made was like a local and a global, had a global mode. So basically, so the first image with it, which is here, is like a local mode where I'm just loading one sample, and then it's showing the shape, which has like 710 cell names, 5 features, and 220 uh, cells in total. The time step, I think it is. It's a time step. Step. So the alive mass shape will have a shape of 710, which is the total number of cells and the time step at each time point or frame. And we have a global mode which has n is equal to 769, which means all the data, all the files in the Epic dataset have a total number of 2,769 unique cell names. So over here that I have loaded two cells separately. And so we have this shape as a 27695, 374. So the thing is that what this data loader does is, so how PyTorch geometric shape and stuff works is we have to have a total number of like for padding, and we don't know that each cell will have that cell or not. So the total number of unique cells has to be kept there as a default number. So that's what is 2769 we have kept, and we have like padded it completely so that later when the model is training or running, we don't enter into any error of that sort. And so the if we take these two files into analysis, so and put them into the geometric function, so it takes the number of nodes as 5538. So it can also increase the dimension by 2,276. I read in some paper that it might cause that it can mistake the embryo 1 cell to the embryo 2 cell. So it just shifted all the indices and just added 2769 more to it. So if we are having two cells and we are analyzing on them, we have two of the unique cell indices so that we don't mess up with the cell 1 and cell 2. So we have like batch edge index is the two number of embryos and the total number of cells that we have, or the edges that we have. That is 1,02,960,057. Now this is like how the dataset loader actually helped me, will help me in the model. So now every embryo has the same tensor dimensions. So if we want to analyze one with each other, we won't have a problem in that. And there's this dynamic masking function, which is like we have a live mask, and which is true or false, because one cell might not exist at the timestamp. So for that, this mask has to be there. Otherwise, it will run into an error or it might give false values later. And this global and local modes also play a huge part if you want to singularly analyze a cell or you want to analyze it with another embryo. That also is possible. And there's also PyTorch geometric patching, which is like the geometric library which I'm going to use for the GNNs. and it supports all of this. Like there's a certain amount of dimensions and this padding which has to be done before putting the file through this library. So it also makes the dataset compatible for this. So I also gave a small note like why the geometric is used for. It's used for mostly collating the graph samples of different embryos into a single large disjoint graph structure. It means that it won't actually be interconnected to each other, but it will be a single graph structure together. But it can be visibly seen that the two are two different embryos. So these are some visualizations which I just to make sure that the embryo is correct and stuff. So it's not zooming in, but so this is not that important, but the data loader just gave me a visualization of how the data will be loaded. So as you can see, the first one, the white means that the masks are like it's dead basically and not present. So it's slowly showing us that the cell is present over there. And then we have this active cell count. So after a times point, the cell count is dead after that, because the for that specific embryo that is a timestamp, last timestamp. And this is the growth of the cell in a 3D structure way. That's just one embryo that we're talking about. So the plan in the future is like I've been on Twitter, so there was one post where they said that the Mamba architecture is, which I've previously worked on, is basically a state space model architecture, which is set to replace the attention mechanism. So I used this Mamba architecture for my final year project, which was for detecting landslide. That was also an image-based project, and so I'm thinking that if the architecture can be replaced in this one, and so that we can keep up with the state of art architectures, and we are up to date. So also I'm planning to like speed up the progress next week, so I can like complete both week 3 and week 4. Go through all of that, and maybe I can check if this architecture can be replaced in hours, and more of that. So yeah, that's what.
Okay. Can you go back a few slides? The last slide, I think. Yeah, I'm interested in this graph at the upper left. Could you go through? Could you zoom into that, or maybe get out of the slideshow and zoom in? Yeah, there we go.
So okay, so this is basically the cell index, which is I've indexed the number of cells, which is sorted by the birth time, and we have a time bit, which is like I think 220 is the last timestamp of the whole embryo, and it's hiding the cells which is upcoming, and the cell with like the active cells are being shown. So the blue one is the active cells which are being shown, and the white one is the which is not present or it's not born yet. So it's supposed to be like this itself, and so there are 710 active cells at the 220 point, and it's hiding and masking the rest of the cells so that the model can be trained upon that, and it's there to predict the next step.
Okay. So yeah, so the unique cells are just anytime you get an image from in the epic data set, it has a certain number of cells in that image. And then as you move through the timestamp, sometimes it'll pick up cells that divide. Sometimes the cells are in different states of sort of observation, and then that's the cell. It's like a unique cell. So it doesn't necessarily correspond with, like an idealized embryo at all. It's like whatever the observations are in that frame versus another frame. Yeah, so that's one of the things about that data set that is, because you have to kind of, when they did the original lineage tree for C. elegans, it was hand drawn. So it was like, John Solston sat there and he drew out all these cells that he saw in different stages of the embryo, and then you observe like a cell division, and so then you have like one cell and then two cells, and he didn't really characterize the transitions because it wasn't necessary to describe the tree. But in the epic data set, you actually have sort of intermediate states, if you will, where you have cells that are kind of there and maybe transient to that observation. So that's kind of interesting. Um, so yeah,
So
it's a lot richer
also the
than
thing is that it will be tested on this data set itself. So this masking thing will be more useful in the testing part
yeah,
because we need to predict the next part of the set.
yeah, yeah. So you have to have something to like to add to the predictive model. Yeah, so I mean that's good. Um, then go back to the I mean maybe in the bottom there. Yeah, the bottom. So yeah, we've generated a number of graphs like this over the years. So people have generated kind of in this 3D space. You have the point cloud,
I think
and
it's Plotly that I used. So
yeah, yeah. But like that's kind of one of our key things is to get like the point cloud for the embryo, and it isn't particularly informative just on its own, but it does give you a demonstration of what the sort of the computational embryo looks like. So, if you have those labeled cells, the end states, then you can like plot something like that out, and it might look like sort of a C. elegans embryo at that stage. Um, Now I know we have some things, especially in DevoLearn in that repository, where we were building 3D graphs in Plotly like this, and actually have like a GAN model where we're generating embryos. And I can't remember what the state of that is, but my point is that yeah, we've done work like this previously, so it'll be interesting to go back and kind of review that and see how that is. Because are you using a standard attention model, or are you using Mamba 3 for this, or is this just kind of a characterization of the?
So I still have to see if it's adaptable to my model yet because this is a whole pipeline and
Okay.
the EAM, the module is just a simple single part of it. So I have to see if the architecture is replaceable. If it's replaceable, then it decreases the complexity and the computation by 30% or something. That's what the
Wow.
paper said.
Okay.
So, and even NVIDIA is looking for Mamba blocks to replace attention blocks. That's what I read.
So the Mamba blocks are 30% more efficient than attention.
Yes.
Yeah. We were having a conversation about this months ago in the Saturday meetings, about like attention mechanisms and how what comes after attention or what are alternatives to attention. And it was this kind of a question I think that Morgan posed. Actually, I think he's having a conversation with someone at the tower about it, and like because you can have. I mean, attention was sort of there was that paper, Attention is All You Need, which was sort
Yeah,
of a
exactly.
provocative title because it obviously wasn't all you need. But, and then that was like the standard for a while. Now people are like, well, we could probably improve performance with something else. And so I'm always interested in seeing what the alternatives to attention models are. What do you think makes this better than attention, the Mamba model?
I think the block architecture and the weights put after one another, like they used a lot of like multi-input, multi-output structure, which they call it MIMO, they call it. So
Yeah.
that's something. I still have to read a lot through it. So
Okay. Well, I mean,
but it does, yeah.
is this something to keep in mind? Yeah.
Yeah.
So yeah, this looks good. So yeah, and so this is this week. Did you do a pull request yet, or?
No. I'm planning to like present every week, and then after getting all verified and stuff, I'll put in a pull request.
Okay. Yeah,
That's what I'm planning.
that's good.
Also, you're saying that my project was more inclined to the DevoLearn library. Is that something?
Well, we have the DevoLearn organization, and we have DevoGraph, and then we have DevoLearn. Now, DevoLearn is it. This, of course, what you're doing is DevoGraph, but there's a lot of stuff in DevoLearn that is like, we were doing some interesting things there in terms of image processing and other types of things, a little bit of networks, but not, a lot of that. But there is a lot of stuff there that's sort of out of date or, is kind of relevant to this. And in fact, back in 2022, when we started this repository, if you look at the documentation, Jia Hong Lee, who was a GSoC person that year, developed this sort of pipeline for the development of the projects. Like stage one was image processing, getting data from microscopy images. Stage two is developing the networks, and then stage three was like a higher order analysis, like topological data analysis or something like that. And we've worked on all three of those stages. And then kind of when we started working on the hypergraph stuff, we kind of moved away from that model, and that just kind of got stages 2 and 3 there got subsumed by the hypergraphs. And then stage one, we're doing some stage one stuff, but I just think it's probably kind of maybe interesting or useful to go back to DevoWorm and look at what's in that repository and maybe improve upon that, because we haven't done much with that in a while, and it's just kind of if we're because I think if we're improving upon attention models, or if we can, then we can also incorporate that into DevoWorm.
Okay. So one question I had when the projects were released is, why are we focusing more on, like, DevoGraph has been going for the past 3 years, right? So, or 2 or 3 years.
Yeah.
So why have we like shifted from DevoLearn to DevoGraph?
I think it's
for the projects for GSoC.
Yeah, I think it's because we've been doing the GSoC project. Like, like we were doing DevoLearn, and I'm going to release a video on our history of GSoC soon. But we started with kind of like it was just basic image processing. That was like the first project, and then it kind of built up to this pre-trained models approach. And then we started building sort of this pipeline of image processing for developmental biology. And then that kind of reached its peak in like about 2023. And then we've not pursued that. We've chosen to go with DevoGraph instead of DevoLearn project. But, again, there's going to be a component of image processing in the DevoGraph projects. So, yeah, we should kind of think more holistically about it too. So,
okay.
Yeah. Well, that's great work, Barshan.
All right.
So, what are your plans for this coming week?
Okay, so the plans was to make those attention modules, and I'll start training on them this week. So let's see where it gets. I'm trying to fast forward through week 3 and week 4 also, and because then I'll have more time to think about the visualization parts, and also about the change in architecture if I want to do some. So it's better to fast forward it through.
Yeah. Well, that's good. Looks like you're on track here. So, yeah, thanks for presenting. And you're going to do a blog post and a pull request soon.
Yeah.
All right. Yeah, I look forward to that.
Okay.
Thank you. All right. So it's Barshan. So did we have other people wanting to go? Ashu?
Actually, sir, I have shared the documentation for the functional hypergraph and hyperages.
Okay. Yeah, I did see that. Do you want me to pull it up?
What's it?
I can pull it up on my screen. Do you want me to do that?
Yes, sir.
Okay. Well, we'll go over it in a little bit, but so yeah, this is something that Ashu put in the Slack, I think. This is the documentation for the functional hyperedges, connecting embryonic development to future neural circuitry. So this, she has a repository that I forked in DevoWorm, in the DevoWorm. It's not in DevoLearn, it's in DevoWorm. So it's github.com/DevoWorm. And this is the documentation. So this is functional hyperedges. And then, so this is just the documentation for what's there. So the first one is functional hyperedges and feed-forward loop motifs. So this is, it's kind of a cybernetic model of going from X to Y to Z. So you have this 3-neuron motif within a connectome. This is what you see in the adult C. elegans connectome. And so just thinking about these different groups of cells and how they're wired together. So this is where we have this 3-neuron motif with the following structure: A to B, A to C, and B to C. And then we're using X, Y, and Z for the notation here. So we have X to Z, X to Y, Y to Z. And so that's, kind of where you have this nearest neighbor connectivity, but you have this shortcut as well that goes forward. And that, of course, is different than a feedback motif where you would go from Z back to X. So you'd have this forward path and then this backward path. In this case, you have a forward path that's nearest neighbor and then a shortcut. So using, unlike a standard graph edge, which connects only 2 nodes, a functional hyperedge represents the entire 3-neuron motif as a single biological unit. So this is, let me see, a functional hyperedge is a higher order relationship connecting embryonic cells whose descendant neurons participate in a common feed-forward loop motif in the adult. So this is of course the motif in the connectome, but then we also have to think about this added dimension of time and how we get new nodes over time. So this is a theme that we've had in thinking about the developmental connectome, which is it's not just about static nodes and looking at their connectivity, because the connectivity can change in a connectome even if we have a fixed number of nodes or a fixed number of neurons, but also when you add nodes or sometimes take away nodes. If you have a mother cell that divides into 2 daughter cells, that mother cell is no longer in the network as such, and in fact the daughter cells then occupy that place +1 in the network or in the connectome. So this X, for example, would divide into X1 and X2, and X1 and X2 might be in different locations, but they also might have different multiple connections to Y. So this is the basic motif, and then of course you can elaborate on that motif. And so why is this important in developmental biology? Developmental data sets typically describe cell lineage, cell position, cell movement, temporal organization, but they do not explicitly capture how cells will eventually contribute to neural circuits. So 2 embryonic cells may originate from different lineage branches and remain spatially distant throughout development, yet later become part of the same functional circuit in the mature nervous system. Yeah, so they have, when you get a division event, they have to sort of reintegrate into this network. So it's not just enough to say that it's maintaining the structure. It may not, but in C. elegans, of course, everything is deterministic. So usually, if the mother cell is kind of associated with another cell, then the daughter cells will be as well. But representing this as a hypergraph is important because you have all these changes in the sort of the local structure. Being able to group them is useful. Then functional hyperedges introduce the missing layer of information by linking embryonic cells according to the neural motifs they will eventually form. And then we use functional hyperedges to provide a biologically meaningful prior derived from the adult connectome. By incorporating future circuit membership in the developmental hypergraph, the model gains access to information that is not available through spatial lineage, or temporal relationships alone. So the benefits of this include improved representation of long-range developmental relationships, so these shortcuts through the network. And I think we talked about um, how you can have these sort of shortcuts manifest as these rich club neurons. So the rich club neurons are shortcuts through the network, uh, where you have like a hub that's highly connected to other nodes. And a lot of times, what these rich club neurons will do is serve as a shortcut between different parts of the network. So between the right and left hemispheres, or maybe like the head of the worm and the tail of the worm, and they're connected in a fewer number of hops than would otherwise be the case if you just simply had a system where nearest neighbor neurons communicated with each other only. That would take a lot of hops, and it would take a lot of the processing time would be a lot longer. And so and the network would be less robust. So there are a lot of benefits to having these shortcuts. But of course, with this, we're looking at improved representation. And the second point is identification of cells that contribute to the common neural circuits despite developmental separation. And then third, enhanced biological interpretability of learned embeddings. Okay, so then we had the lookup table. This is where she built this lookup table. It's in the GitHub repository. So this is an example of the table. And so each row here represents one feed-forward loop motif and one functional hyperedge. So we have, a number of rows in the data set. We have a motif ID, and then we can go back and look and see what the contents of that motif are. The adult neuron columns identify 3 neurons that participate in the feed-forward loop motif within the mature connectome. These neurons are then mapped to their embryonic lineage identities, and the resulting embryonic cell triplet forms the functional hyperedge represented in the developmental hypergraph. So there's a weight here that sort of corrects for, differences in different motifs. This is, of course, tells us a little bit about the functional lookup table and its significance. And then, the significance is which embryonic cells will later participate in the same functional neural motif. By answering this question for every feed-forward loop in the connectome, the table creates a direct connection between embryogenesis and mature neural circuitry, enabling future functional organization to be incorporated into the dynamic hypergraph framework. So we have the fork here. This is in DevoWorm group. This is what I described before. This is dynamic D-GNNs and Hypergraphs. This is, I have to refresh this fork at some point. But this is basically what she's got in the repository. So this is output tables, the raw data set, the README, and some PY files. This is where we're building this anastomosis structure. So these motifs actually contribute to some of the questions we're asking about morphogenesis and this connectome model. So the connectome model doesn't imply morphogenesis. It just describes connections between cells, in this case neurons, but you can actually build other networks, other types of cells that are adjacent to one another or connected through physical connections like gap junctions or other types of physical adjacencies. And so, but we're interested in the structure, sort of the topological structure of these networks too. And so part of that are these anastomoses, or these structures that are joined by small bridges. And you see these sometimes in anatomy, but we're using this term more generally in terms of a network that are almost like these weak connector links. So if you're familiar with network theory, there are these weak connector links that connect two parts of a network. And so that's what she's focusing on here with these anastomoses. We defined this term in the preprint that we did on hypergraphs back in 2023 for DevoWorm. So check that out if you really want to understand like what the concept is. Then we have the functional lookup table here. So these are PY files. You can run these and get demonstrations of this. Then we have the motif grid, which is an image. This is showing these different motifs and examples of that. And then this is the notebook, so you can run this interactive notebook. Okay, and then that's your documentation. So is this like a draft documentation, and then you're going to put it in the repository later?
Yes, sir.
Okay, yeah. So I mean uh, one suggestion here is that this part here, if you could label these like consistent with the labeling A, B, and C instead of X, Y, Z, that would be good. Just to be consistent in that.
Yeah, sir. I actually put that figure in last by mistake.
Oh, okay. And then if you're, if this is in Markdown, link to some of the other parts of the repository where you have some of the code. So like if you're kind of doing a demonstration, show some of that. Just the link. You don't need to put images in, but just the links to different things.
Actually, in the repository, there the demonstration is there only, like in this feed forward motive grids.
Okay. Oh, I see this. Yeah. Yeah, this is good. And then we have some of this stuff. So yeah. Okay. Yeah. Well, I look forward to seeing that in the repository. Yeah. Thank you for your continued work on that. Okay. Okay. I don't know if Kavya wanted to give an update or had anything to update us on.
Yes, I was just looking at what's already explored for the project I was doing. So I went through affective computing, social learning, and Michael Levin's work on stress sharing. So those are some interesting topics, but most of the work which I was thinking for the agents research project were already being implemented, and I just wanted to know if there's anything specific like you want to do or some goals for it.
Well, I mean, right now, I don't think there are any big goals that we want to. I mean, if you, the first thing I guess you would do is like show like a short presentation on what you wanted to do, and I'm pretty open to a lot of different directions. I mean, we don't want to go off in every direction, but I think if you have any, something you contribute based on like reading the prior work, I think that's something we can evaluate to see, what the value is there, or what the really interesting questions are there. So just go back to the work and think, okay, what is the thing that I can add to this? What thing is missing that I can fit myself into, and then we can worry about what exactly that looks like later. But just kind of think about this is what I want to do based on the prior work, and then just like prepare a short presentation and show us like how you might do this, but more importantly, how does that fit into everything that and you can fit this into like open source sustainability as well. There might be a bridge there that you can demonstrate, and if that's the case, all the better, because we can then use that more. I think it's more useful that way.
Yes, I was actually looking a lot into the active inference part and the affective computing, like how stress affects active inference and precision and all. So I think that is also linked to the open source sustainability. Also has some active inference project, right?
Yeah.
So, on a similar note, I just messed up my hair entirely. On a similar note, if you are looking to be pushed in a particular direction about stuff, do what Bradley said, basically. However,
you mentioned like some Levin stuff and some Krakauer stuff and everything else, or you mentioned a bunch of things. There is there's things that I'm working on with Avery that fit in a kind of multi-agent, and is like, I get, I would basically say let's like talk or DM after the meeting today, or sometime this weekend, because there's stuff that's cooking in some other groups that could be easily ported over into things here as well. But it's really just going to be a matter of what you want to do. Some of the stuff that I have in mind that Avery's working on in terms of like some DigiNet stuff and some, I don't want to say personality stuff, but things that are sort of active interest or individual variation of agents related. Like there's some inertia there. It's just not in like any of the existing Breitenberg vehicle stuff in the past. So I would say do what Bradley said first, and then talk to either Bradley, myself, or me. Bradley won't know about the other stuff that I'm talking about, but basically I would say talk to all of us, and we can point you to, if you want to work on more of the classic Breitenberg into active interest stuff, that's great. And if you want another option where there's some other people working on something that's in a slightly adjacent area, but in a computational and simulation related sense, those seem like two paths that you could go down that are both fruitful.
Yeah, I'd really be interested in sort of the active inference angle too. Just
Yes, I will surely connect with both of you.
all right.
I think by next week I'll try to bring up something more concrete and present.
Yeah. Don't feel pressure on like making it perfect. Just kind of throw some ideas out there, show like how, like, what basically what you want to do and how it connects to other things.
Yeah. And even I would even go further. Like you said, you looked this up, and a lot of things you thought about were already implemented. That's fine. I would encourage this for everybody here, especially first-time folks or younger folks or other people in our general community. If you see that, that's not a problem. That is not a sense of, oh, I don't have anything to do now. I can't do anything. No, actually, that's the bridge of the conversation that you have with people like me and Bradley. You say, hey, these guys did something that I want to do. Where are actual next steps? And so that's not a problem or a roadblock. You may not have enough context of the problem space or the tools that are using or what's happening on the project, but that's where you can really start a conversation about what to do. So don't see it as an ending. See it as, or even if it's a simple. I've had to do this, or I wish I knew I should have done this sooner. Where it's like you basically see, oh, I really like this and this and this, and this guy has this solution and this happened here, and you're presenting things that aren't seeming like open questions, but part of the point of advisors or mentors or ideally older people in the field who are going to act as a mentor to you is that they will be able to dialogue with you about the context that generated the current solution and where things could go differently. So don't be put off by that. That's my message about that.
Yeah. Thank you. Yeah, that's good. Let me see. I have another thing I want to talk about here. So Jesse posted.
Oh yeah.
So Jesse posted this in the Slack as well. This is a Hugging Face repository for this group Society and Ethics. So do you want to talk about this a little bit, Jesse?
I don't have anything very interesting to say other than I'm wanting to look into it more. I just saw on a whim. They might seem like a really nice way to blend some of the technical things, both from data indirection and society ethics tech, and I'm really curious. What I want to find out, I don't know if I think Morgan and you might have more experience with Hugging Face in the sense, but I don't know if you have any experience with this group within it, or like, I don't know, collective within it. I don't know the best way to join or contribute with them, or try to cross collaborate on some things. This week I also saw some things from the open benchmark, I think it was. But just I've just saw a few things this week. It's like, oh, like here's some interesting things to look into about that. So I don't have anything concrete to say about that. If anything, I would say more about the how to speak and tell a story professional thing from last week that I have a little bit to say on, but not so much that Hugging Face yet.
Yeah, just. Oh, go ahead.
No, it's sorry. I'm on my phone, so I can't quite see what the links are. Which Hugging Face thing is this?
This is a group called Society and Ethics on Hugging Face. So it's huggingface.co society-ethics.
I think it's kind of, from what I can loosely tell, I think it's just a collection of people. Yeah, it's a coalition of people throughout Hugging Face. So I don't know that it's like a formal. I don't know. I really don't know what it is. So I mentioned it to kind of look into it more, and hopefully you guys have some ideas.
Well, it looks like there's like a collection of things that people have done that they're contributing to this. So it's like the one place where you can put this all and together. You have archives, a model card regulatory check, just different types of things that people are doing. It looks like you can request to join the org. So from what I understand, Hugging Face has organizations and you can join them. And we have a DevoWorm Hugging Face that was set up a couple years ago. But yeah, so what does Barshan say?
Interesting.
It was a quote from the page we just read.
It's a coalition. Yeah, so this is, we could look into this further to see what, if there's something we can contribute to it. I know we have some things, some legacy things around that we might be useful there. And then the open benchmark. I know that's something we talked about in previous meetings, open source meetings, and this is this whole thing about benchmarking different models and that whole thing. Or we have, of course, our DevoWorm Hugging Face, so we might want to update that with some new content. Okay. Yeah, Morgan.
Yeah. So that's interesting. I'll definitely check that out. The Hugging Face started an initiative. It looked like they were kind of hoping like organizers would come in for particular topics. One of those is PDEs, and I've been toying with trying like doing hypergraphs here, and with a bit of a focus on physics of network, or related and other like related topics to PDE. Anyway, this is another project that just got started. Hugging Face. I'm sorry. Terminal Bench.
Yeah.
And Terminal Bench Science. That's interesting as well. Speaking of benchmarks.
Yeah.
I recognized, both Russ Poldrack as well as Stephen Bowman as part of it, and I wasn't familiar. I think it's Go Harbor. It's one of these. Yeah, but so I followed up yesterday. Just in terms of sorry, like getting this running. I wasn't sure what Harbor was like. These seem to be, some open source tech projects that are like infrastructure layer thing, but it was night. I showed up for and then another tech company like kind of trying to put their alternative. I don't know if people are familiar with Modal. Here in San Francisco, their ads cover every single bus. Um, but it's we actually Elliot knows him. Like their CTO is a big guy, and he has some connections here with the tower. Anyway, like I'm always looking at new resources.
Yeah.
So like I got, because I went to this thing, I got signed up with Beam, some open source, infra alternative to Modal. Anyway, they're letting me use GPU compute. I've made a few tasks for this terminal bench science, and yeah, so I forked it. You can find it in my repo, on GitHub, and a focused ultrasound and a fusion imaging. So, and it like an inverse problem task. But I'm really kind of hoping that through this find more people. Like this isn't quite it. First thing that was more like agentic SciML.
Yeah.
But how to really tackle your problems, like that was the benchmark. Where I see like getting into the weeds, it's just like they're actually looking for much more modest tasks. But like in terms of compute, there's still supposed to be like a typical pipeline. So something that like say neuroimagers would want to do on a regular basis.
Right.
And you kind of like you drop an agent into this particular task, and the agent should just figure it out and get the context, figure out what it should be doing. I kind of knew for it.
Well, good.
So
yeah,
I've got several, like part of getting a task ready for that is to help. I've also been recently, because of all the kind of like benchmarking of foundation models, I've been using this approach of renormalization group theory. If anybody's using foundation model, there's some interesting here that I'll share his paper too. He's got a on it, but you can find this particular project for that.
Yeah, we talked about this in our Saturday meetings. This is benchmark or diagnose different neural network type models.
There's lots of people using certainly renormalization group. Friston had a paper, I think, here more related to brain imaging, but I'd like to find more. What I like about Charles is that he makes some prediction. So it'd really be nice to find more kind of like model-based approaches for this kind of work.
Yeah. All right. Yeah, it looks good.
I don't know
Right.
how much time we have or what else you wanted to cover today, Bradley.
Oh, we have about 5 minutes or so.
Oh.
I don't know if you had. Well, you can have your discussion on what it was you were doing.
I'll do a preview. Well, yeah, go ahead.
Okay,
Barshan.
go ahead, Barshan.
Well, I had a small question. Since we're talking about the society and ethics, so does this fall under AI safety, or are these two different things, or are they a subpart of each other, or something like that?
When you say society and ethics, what are you referencing?
I mean, maybe this Hugging Face, these values that people are going through.
Do you mean like broadly in the world, or like in the lab? Because like
yeah, broadly in the world. Like
I don't know. Do you guys want to say anything? I can say something about that, but I don't. I mean, in one sense, I say society and ethics. doesn't fall anywhere. And what I mean by that is like I don't think anybody particularly cares about it. And I don't mean in a defeatist way, but like there is no, the only people that are like actively pursuing it are people that are very intentionally focusing on it. Like it's not like you're not, society ethics is not going to come up in like most existing programming. Like there's certain ethics and technology stuff, but like what was your question more like, what is this relation to like AI safety as a field of study, or like what were you going with that?
Yeah, so basically the goal of AI safety is to understand AI model, using it, having policies and governance for it. So does ethics also have like a goal like that, or is it just like some?
No, and I mean I would even say there's many different schools of AI safety. Like when I think of AI safety, a few years ago, like AI safety meant very long-termist views about, well, we need to figure out the way to bring AI AGI into the world in a proper mechanism, and like there's philosophical schools of thought that are deeply embedded in some of those spaces, and there are entire legions of people trained in AI safety through long-termist views about what that means. And that you're right to say, like you're right to bring up a point though that like that's not, anything that's all of these like new-ish fields of study, or I don't even want to say new, but like there's no, there certainly isn't a unified goal of society and ethics. Maybe in that program at Hugging Space there might be, but there's certainly not like people can't agree on that at all. Like that's part of the problem is like if you go to EU or this country or here in Europe or in China here, people care about stuff, but there's not the world you're stepping into is a world where people have not resolved a lot of foundational challenges about, in kind of this could be another topic. We talked a bit about nascent science a while ago, but like in a Kuhnian pre-paradigmatic sense, you might be able to say we're somewhat pre-paradigmatic about like society and ethics. Because I asked you the question first too, because like, society ethics and technology is a working group that we made in this lab like 6 years ago. It's like that's somewhat clearly defined, but not like the field of even like one thing that I think is really challenging for people, and this is a tangent, and Bradley and Morgan can counter this and speak to this. I think it's very challenging for perhaps people coming into the space right now to see the plethora of terms that are just emerging. Like a couple of years ago, I remember asking one of my best friends here in Boston. We go to like tech events and stuff. I was at I think it was AI Cures like 2023 or 2022. There's a picture of me with it somewhere on the Medium and stuff. And I said to Dan, like, what is responsible AI? Because it was like the term of the moment. Like, oh, we're doing responsible AI. And it's just like, now it's sort of like human flourishing is kind of the term people use to be a little bit more people positive in ethics. Like that's the MIT it's about human flourishing and I think there's like tech ethics is long-standing history. Like one of the first programming ethicists back in the day, like even talk about like Ada Lovelace and stuff like that. But Norbert Wiener and The Human Use of Human Being was a book that we covered from like the 1950s. And he, like, if you look on like programming ethicist on Wikipedia or something, it was like, oh, this kind of came about from people kind of concerned about that back then. So the whole field, I would say, is quite unstructured, especially in the public sense, with niche schools and clusters of development over the last 50 plus years, and more so recently, especially with the prevalence of AI and whatnot. But yeah, I don't know. that's a lot of context and a lot of sort of not answers in the negative category of no, there's not some things that maybe should exist. But anybody else want to comment on that or questions?
Why don't we do like a 5-minute thing on the thing you wanted to talk about?
Yeah,
Yeah.
I'll do a preview.
Okay.
And the preview will be useful since I'll ask a question. What I'll get into next time is this. Can you guys see this?
Yes.
Is it like the right size to see on your screen?
Yes.
Okay. I set this like super generated quickly thing. But what I will definitely go into more next time is this. And I added, and one thing that you'll get used to, because Barshan kind of mentioned like telling stories, and we've had previous conversations about how do you talk to different audiences. One of the things that I before I get into anything, this is like pre you I'm kind of making a bad example because you don't want to start this, which we'll explain. But I think one of the most interesting parts of this process is when sometimes you'll see academics before a conference like a last minute slides. And some of it's because academics have so much stuff to do and last minute stuff and all this other pressure motivates people, blah blah blah. But sometimes you're really tailoring towards what came up in the conference or what somebody said as well. And Bradley's done this much longer than I have, so I'll defer to you about that. But I wanted to mention, I added this part 1 vintage advice part because if you guys recall, there may have been a discussion in the Slack about this, and I mentioned certain videos, which I'll loosely talk upon and go more into next week. But I realized during making it, like, I really want to phrase this as some vintage advice. And in it, I'm going to talk basically about two different approaches. And one of them I'm going to say, here's some really long-standing things that I think still work. And one is going to specifically talk about something that I think is quite outdated, but will work really well if you're talking to basically someone older than me and past. Like if you want to sound really cool to certain generations, there's a specific way to garner attention and talk like you know what's really going on. And I'm going to get into that a little bit more next time. But as a general preview, I'm going to mention 3 classics. I was actually going to only talk about 2 today, but since we're out of time, it's just going to be a total preview. And the way you talk about it, according to Winston, is like open with a promise, as opposed to, oh, my name is fumbling around. How to keep the room with you as you're going through stuff, and ending in a way that kind of gets them stay with you. So there's not going to be any specific content. This is all like principles, and that's kind of why it's a first part and a bit vintage. But we'll go into like these different approaches about it. I will highlight this and come back to it later. This is a slightly LM. This feels so LM generated, the title, but like the order nobody tells you. Basically important how to speak, your ability to write. These things are things that reach other people more than the actual quality of your ideas. This is something that Larry McInerney of Expert Writing really gets at too, is to condition you out of like, your ideas can be the best in the world, but you have to find ways to do it. And I don't say that to communicate the value of them to other people. And I don't say that as a means to say, oh, I'm not a good speaker, I'm terrible, I'm doomed. But much more, I think the goal is much more to see that as like something to continuously refine over your career is, okay, how do I integrate? How do I learn from this? And how do you understand what your own like personality or speaking style is and not try to go against it, but just let flourish what you do have. So that's sort of a broad thing to think about. And then later on, I'll get into the 2 people. The 2 people are basically, and I call this vintage, there's 2 old white guys telling you how to talk about stuff. I think there's a point to what Connor Neal talks about. This is very old. This is 22 million views. This was the big thing, and it's a great thing to know how to do. He leans a bit into profundity and awe and talking with these kind of dramatic things that you've kind of seen a lot of like classic TED talkers maybe use. And there's a time and place for it now. But I do think it kind of is like, if you ever watch old commercials from like the 50s and 60s, or from like even the 80s and 90s, and things that like your grandparents are like, oh, that's the way to be convincing and to be a reputable brand, like that's changed over time. Interestingly enough, I think a lot of things from Winston on the left here still hold very well. And a lot of Winston's stuff is talking about like a kind of a limited set of heuristics or like shortcuts or simple methods you can apply without having to do a bunch of other things. And I think they hold up quite well. So we'll get into that next time. I'm just going to breeze through all these things. I will critique Connor's stuff, but I think there's stuff to take from it too. A little bit dated. I was going to mention this one from Duarte. And look at this terrible. I think this AI generated graph is supposed to be the same as this, which I think is just quite funny. It's this up and down kind of zigzag, and then it's like, here's some lines. But we'll get into that later and show you the point of like you got to check your slides whenever you're presenting stuff. Like even if it's like this, like just be aware of it. Like, oh, you had to think really quick, you had no time. Be aware of it. And point it out as saying, here's the limitations of what you're dealing with. But we'll cover this. We'll cover this next time. And this is, I really like the idea of leaving with what to take away with you, as opposed to just thank you and here's our notes and see me after the questions. But like leave. I think one of the most awkward points of presentations is when you have your conclusion slide and you kind of spend time going all the way back and forth. Like, on slide 12 you mentioned. And it's like, if you can curate like a little bit of a summary of that at the end slide, that's a nice thing to do, because at least it helps the facilitation process for other folks. So this is like a flash talk within a flash talk about all this stuff. But next time we can spend a little bit more time on what does it actually mean. And even if I kind of made this to be like a 10 or 15 minute preview so that you go back and actually look at these things yourself, or put one in the Slack and mention something you'd want to talk about, like, oh, I found this other video, or like I read the Duarte video, or whatever, or this person says this. Like, feel free to contribute to the discussion that way, because we can talk about it more next time. So yeah, I'll leave it at that. Any initial questions? I know we're kind of out of time for today, but happy to follow up later too. Okay.
I think that's good. Yeah, thank you.
We'll all be highly anticipating vintage advice on how to speak to people and do presentations next time. But yeah, it's great to see everybody today.
Right.
And for anybody who wants to talk about your projects, like reach out and dialogue to us about it. We'll go from there.
All right. Yeah, that's great. So thank you, Jesse, and thank you, Morgan, and Barshan, and Ashu, and Kavya. Yeah, so let's keep working on stuff, and see you next week. Thank you.
See you guys. Bye.
Thank you. Bye.